Define and defy, hackathon, Morales and Google. 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 Define, hackathon, Morales and Google. Define and define, hackathon, Morales and Google. Define and define, hackathon, Morales and Google. Define and define, hackathon, Morales and Google. 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 Morales and Google.
Greetings, developers and hackathon participants. Welcome to the final live stream event, other than the closing ceremony, of Defining DeFi. Thank you so much for being with us for all of these workshops. We're joined again today by Rahat of Polygon, and we're going to be doing some live coding, learning how to code an ICO contract on Polygon, and we're obviously taking questions and things like that as well. So before we get into it, let's invite Rahat here to the stage. How are you doing today?
Doing good. How are you, man?
Very, very well. Glad to be here with you for this later stream than normal. This is actually one of the later streams that we do, since we typically follow, European time zones. It's nice to have one that's more in the evening, even for people who are, in New York time. We're approaching dinner time already. So great. Anything... Since this is the very last workshop stream, I guess I just wanted to take a second to thank Polygon and our other sponsors, BNB Chain and Phantom, as well as Acceler and Multi-Chain. All of these sponsors came together to put on a great event for us, and everybody had great workshops. And we're really excited to have Polygon here to close out the final one. And so if there's anything extra you wanted to say before we get into it, now is a great time for that. Otherwise, if you want to share your screen, we can just dive right in too.
Yeah, I think we can probably just dive into it. Hoping this one will be a little bit more fun. We're going to do some live coding from scratch and see how that goes. So I'm going to present my screen. Cool. Is that showing up? Okay.
It is now. Just taking a second to pop up there, but awesome. We can all see it now.
Cool. So I did say live coding, but there are just a couple of slides. So we're just going to go through those really quickly, and then we're just going to kind of dive right into it. But today we're talking about building an ICO contract on Polygon. So really quick, if you haven't seen me before, I'm Rahat, lead developer relations engineer over at Polygon. Got some front-end engineering and Solidity engineering experience. And these are some places you can probably find me. But today, and just also real quick about Polygon. Polygon is one of the leading platforms for Ethereum scaling and infrastructure development. We provide a whole bunch of different types of tools where you can build on top of and launch your dApps. Today's focus is going to be just building on the Polygon proof of stake chain, which if you're already in kind of in the Web3 space, you may have already heard of and been using. It's pretty much like our premier product. There are multiple other products that we now have out in public testnet working that you can try out, but this is the one that we kind of started out with that gave us our bread and butter, so to speak. So what exactly are we going to do today? It's going to be fun. I'm going to be writing a very basic implementation of an ICO smart contract from scratch using Remix. So we're going to discuss how that basic implementation of an ICO contract would work. We're going to live code it on Remix. We're going to discuss like other features we can add. There's like a whole bunch of things you can add to an ICO contract. We're not going to go through every single one of them like live. That takes quite a lot of code. We'll talk about what you can do to kind of like further explore and build on top of this. And then at the end, if you have any questions, I'm definitely happy to take those. One important, very important thing, you should probably talk to someone who understands taxes and laws before doing something like this on mainnet. I do not understand any of that stuff. I am a humble developer who can show you how to do some of this stuff. Whether you should do it or not is not something I can tell you. So none of this is financial advice. The code that I'm going to be building here is unaudited code. So don't expect to just like copy and paste and like deploy it on mainnet. It needs to be reviewed. It needs to be audited, especially if you're like building something in the DeFi world. Auditing is super important. You should always have a third-party auditor, no matter like how many security conscious developers you may have on your team. Auditing is super important and needs to be done. But we're going to be building a basic ICO contract with an allow list, essentially allowing you to create a coin with however many, initial coins that you want to mint. It will be minted, sent to a smart contract that will handle all of the ICO kind of logic. And based on that, people will be able to buy in to that ICO and receive some amount of tokens. This will all be able to be done on the Polygon testnet. So I will give you instructions on how to deploy this on the testnet as well. But to get started, I'm going to pull over Remix into the screen. So you'll be able to see that now. And I've got already two. So if you're unfamiliar with Remix, this is remix.ethereum.org. Really cool spot for just like diving in and writing some Solidity code without you having to build out like kind of like write out some scripts for deploying, worry about your local environment and things like that. Other tools you can use if you want to like have more control over your local environments and all that stuff are like Hardhat, Truffle, tools like Foundry, a little bit more recently. So check out all of that stuff as well. For today, just for the purpose of this workshop, we're going to be focusing on Remix, just so we can write out the actual code itself. So you'll see that I wrote two contracts, or two blank contracts. A coolcoin.sol. Coolcoin is the coin that we're going to be coding out, and an ICO contract. I kept the logic. I'm going to be keeping the logic kind of separate. Coolcoin itself is going to handle the deployment of the actual coin, minting it, and sending it to the ICO contract. And the ICO contract is separately going to handle the logic for everything within the ICO with like allow listing, withdrawing funds, sending funds to folks, etc. So let's start off inside of Coolcoin. Inside of Coolcoin, I am going to just copy and paste just some small bit of code that I had from before. And what this is basically going to do is set our license for this. I'm not going to license this, so you can do whatever you want with it. Set our Solidity version. I'm going to eventually import the ICO. So let me actually import the ICO and not Coolcoin itself. There we go. So let's start off with the basics here. I'm going to be leveraging OpenZeppelin's ERC20 contract. OpenZeppelin is great in the fact that you don't have to reinvent the wheel every single time. There's no need for us to have to like rewrite transfer functions, rewrite like all of the basic things of how like ERC20 tokens are implemented over and over again. ERC20 token from contract from OpenZeppelin will give us a lot of that baked in functionality that we need just to get started. So we're going to go ahead and write the initial contract and say Coolcoin is an ERC20. And all that means is that I'm inheriting all of the capabilities of the ERC20 token from OpenZeppelin. there's two things I'm going to keep track of here. I'm going to come back to this in a little bit, but those two things are going to be an address called an owner, and another address is going to be the ICO address itself. Now we're going to write a constructor. I can spell constructor correctly. Yes, I spelled it. And the constructor, we need to also initialize the ERC20. It's going to be called CoolCoin. And it is going to have a symbol of CC. How did I know to write this? I checked the Open Zeppelin documentation for this specific contract. So definitely make sure whenever you're using an Open Zeppelin contract, check out the documentation first. But I know that to initialize the ERC20, I need to give it a name as well as a symbol, which is what I'm doing here. Now, what we're going to do is set the owner to be message.sender. And the ICO is going to be casted as an address. And we're going to deploy the ICO contract when we deploy the CoolCoin contract. So to do that, I'm going to say new ICO, and we're going to pass it to arguments later, but we haven't actually written the ICO contract. So I'm going to come back to this soon. And we're just going to mint. So underscore mint is one of the functionalities we get access to from ERC20. So we don't actually have to write a minting function ourselves. So underscore mint, and mint takes two arguments. First, an address that the coins need to go to. So we're going to send it to the actual ICO address. And then we're going to mint 50,000 tokens. But to do that, we need to actually multiply this by 10 to the 18th power. Because whenever you are writing these like units in Solidity, Solidity looks at this at like the tiniest value, which is Gwei. So if you multiply that by 10 to the 18th power, you would get the actual full amount, whether it's Ether or Matic. So that's going to be 50,000 tokens. And cool. Okay, no worries. Well, we're going to come back to that in a second of why that error is coming up. But cool, this is my very basic like ERC20 token that handles just minting the function and sending it to an ICO contract. So let's make sure the ICO contract is actually written. Now, what's going to happen here, I'm going to actually have to bring in the CoolCoin, and you'll see why in a second. But the contract on this side, we'll call it ICO. That should get rid of the error here. Yep, because now we're importing ICO from an actual contract that has the ICO contract. And there's a bunch of variables that we're going to look at here. Two variables at the beginning are going to be called constants because those are like never going to change. But what we're going to do is for this specific ICO, whenever somebody contributes to our ICO, we're going to give them a certain amount of CoolCoin. In this case, we're going to say that whatever amount of Matic that you put into this contract, we're going to give you 2 times that amount of CoolCoin. So we're going to have a unsigned integer, public, use that constant keyword, and we're going to call it ICO exchange rate. And we're just going to say that's 2. The amount back. We're also going to put a limit on how much folks can actually contribute. So we'll have a contribution limit of 200 Ether. Although I'm writing Ether in here, because you would be deploying this to the Polygon blockchain, Ether is interchangeable for Matic, but in Solidity, you just need to write Ether. And we're going to have a few more things. We're going to have an address public, which is the owner. That owner is going to come from the smart contract we deploy from CoolCoin. CoolCoin, we're going to keep track of the actual CoolCoin address and contract functionality here. We're gonna have a Boolean that has like a public is public Boolean, and we're gonna start it off as false. This basically means once this contract exists, it is not available to the public right away, and we're going to create an allow list that allows specific people to contribute first until the owner of this contract decides to open it up to the general public. So if you have like, let's say some like seed investors or anything like that who you want to give priority, like this would be how like the basic functionality of how you would implement something like that. And then we're going to have a mapping. Mappings are just basically key value pairs. And we're going to map addresses to Booleans. And this is going to be our allow list. So in order for you to actually contribute to the ICO before it goes to the general public, your address needs to be here with the Boolean of true. And we're going to write a few custom errors for later. So to do, write some custom errors. So we're going to come back to that in a bit as we write out our functionality. But let's go ahead and create the constructor. So the constructor we're going to say is going to take an owner, so underscore owner. And it's going to take the actual deployed CoolCoin contract, whatever that may be. And we're going to set the owner to be whoever the owner is from the deployment of the CoolCoin contract. And we're going to have CoolCoin itself be the address that we deploy as well. How do we get that information? Because it's in the constructor. What happened here? Identifier. There it is. That C was supposed to be capital. Okay. Cool. So now we have an error here again, because this is expecting 2 arguments based on what we wrote over here. The constructor needs two of these. So first we need the owner. The owner is just going to be, I believe, message.sender. Can we do that? Yes, we can. Okay, yeah. So we're going to say we have the owner here, which is the message.sender. So we're going to pass in the owner, and then we're going to pass in this, which is just going to refer to this contract itself. It'll include the address, the functionality of this contract, and everything that inherits from ERC20. So now we're all good. We're not getting any compile errors. This is basically the final version of the CoolCoin contract itself. All it does is when you deploy it, it mints 50,000 tokens, deploys a new ICO contract, which is this one over here, and sends that contract 50,000 tokens. And that's it. There's nothing else that needs to be done on this specific contract. So let's focus more on building out the ICO itself. So what we're going to do is just basically add a few bits of functionality and rules for things that can be done during the ICO. The first thing I'm going to do is show you how to write your own modifier. So generally, what you may sometimes reach for when you're building out a contract that needs to work with a specific owner of that contract, you may reach out and use a library smart contract from like OpenZeppelin. I believe they have one called like Ownable. So this is kind of like a way you could like track ownership and only allow ownership, kind of like writing it from scratch. It's actually not like a lot of code. So to write your own modifier, we use the modifier keyword. Let's say that it's only owner. And we're going to say that if message.sender does not equal the owner, which we're keeping track of here during the constructor, then we're going to revert with a custom error that we're going to write. We're going to say not owner and plug in the actual owner in here. And we're going to use this underscore you need this underscore at the end of your modifier. This basically lets Solidity know, okay, modifier is done, continue with the rest of the contract, the rest of the code. So here's our first custom error, not owner. To write your own custom error, you write the error keyword, the name of the actual error itself, and any arguments that you might want to pass. So we're going to pass in the address of the owner. So now whenever this function reverts, because you added this modifier to some function that only the owner can call, this is what your front end or whoever's like plugged into this address is going to see as the error. They're going to see this not owner, and they'll get feedback that the address of the owner is whatever we pass into this error over here, which is the owner that is being kept track of inside of this contract. Cool. So that's like kind of like a basic implementation of like ownable and how you would track ownership without you having to actually import that ownable functionality yourself from OpenZeppelin. I believe ownable has like a whole bunch of other functionality in it, but that's not like relevant to like what our specific needs are. So you should always like look at specific contracts and see like, if I'm importing this, do I need all of the functionality in it? Maybe there's only bits and pieces of it I need, and maybe I can write some of it out myself. Which is why in this case, I very strictly only need to check if this is an owner. So I just wrote my own modifier. So now let's write out the functionality itself of the actual smart contract. So I have a function called, I'm going to write toggle public. So this is actually toggle this Boolean on and off. So if we want to like make the ICO available to the public, or we want to just make it available to seed investors or something like that. So this is going to take a Boolean called toggle, external, but we're going to add the only owner modifier so that only the owner can actually change whether or not this is public or not. And it's pretty simple. We're just going to say is public equals the toggle. And that's it. So the owner has to like say true or false on this toggle. And then once they choose that specific Boolean, that's what it changes to. In some cases, you might see people just say like, oh, just change it to the opposite of what it currently is. The thing is that invites like a little bit of like room for error. Like what if the owner accidentally, makes a couple requests when they didn't mean to, etc. This like specifically forcing them to choose true or false will just make it like a little bit more like specific on like what they actually want and remove a little bit of that possibility of error. I think we're probably missing some semicolons or something. Did you mean not owner? I think I may have spelled it differently. There's always some spelling errors. What I'm doing occasionally is like I'm on a Mac, so I'm using like the Command S feature as if I'm saving it. That actually looks at everything and see if it's like a compilable file, and will give me those errors from time to time. So I highly recommend that as you're writing a smart contract in Remix. It'll help you catch errors like right away. So now I have a function for actually toggling that public feature. Let's create a function that can add to the allow list. So that I'm going to allow the owner to input an array of addresses, right? You can do something like inputting just one address, but that wouldn't be as gas efficient, because if the owner has like a whole bunch of addresses that they would want to add, it would be better for them to do that in one single transaction versus like putting in a whole bunch of them. If you want to become even more gas efficient, you could look into things like doing a Merkle tree, kind of like a Merkle for the allow list. That's a little bit more advanced. We're not going to go into that, but that is something you can look into for making this saving even more gas if you wanted. But for now, I think this is fine. We're going to have a memory. Save this in memory, and we'll just call it addresses with another Boolean of toggle. Is we have to flip this Boolean over here to say true that this address is allowed. By default, if there's an address that is not on this list, it should just return false. So this is going to be external. Also, only owner should be able to call this. And we're going to put a for loop in here. So for u into 56 equals 0. I less than addresses dot length. I always get nervous when I type out a and say allow list addresses at that index equals toggle. So with this, the owner can actually blacklist addresses as well if they always want to keep that specific address false, or add addresses, remove them later on. They would just toggle it to false instead of true. So now we have a way for the allow list to happen, and for people to be added to the allow list. Well, we've got two more functions we're just going to add into this. We're going to create a function called contribute. We want to make money, right? This is going to be external as well. This is going to be payable. Payable allows us to take money. Payable is an awesome keyword in Solidity, which allows us to access things like the message.value, send and receive money within the transactions. So there's a couple things I want to check here before I actually allow the contribution to happen. First, let's check if isPublic is false. If it is false, we're also going to check if this person is not on the allow list. So if they're not on the allow list, we're going to revert and use unauthorized custom error. And we'll go up here and write out our custom error. Unauthorized. And let's say we wanted to add in a message here. So we'll say string message. And we can pass in a message into unauthorized and say something like, you are not allowed to contribute, sir, madam, or whatever. So now, if we know that we are not in the public phase, we need to check if the person is in the allow list. If they are not, we're going to revert. But as long as both of these checks are met, we can go ahead and contribute, do a few other things. To keep this ICO as simple as possible and not have to add a million different things, I'm going to just require that in order for you to contribute, you must meet this 200 Ether limit. So what we're going to do is if message.value does not equal, and what did I name this? Contribution limit. Yep. If it does not meet the contribution limit, we're going to revert another unauthorized. And this time we're going to say you must contribute 200 Matic. Cool. So the reason I'm doing it this way, and in real life, you'd probably do it a little bit differently. You'd probably keep track of contributions over time and then, compare it to the contribution limit. In this case, just to keep things a little bit simple, we're just going to say you can only contribute 200 Matic, right? Just so we don't have to like create more data structures to like keep track of like how much people are contributing, et cetera, et cetera. I don't think you want to actually see me code for that long. So this is where we're going to kind of like keep it to make it a little bit more simple. So as long as we have that, if everything is cool, we're going to then say cool coin transfer sender. We need the address of the person that we're sending it to, and then message.value times ICO exchange rate, which is going to be 2. What this means is we're accessing the transfer functionality that exists on the ERC20 token. That transfer method takes 2 arguments. The address that the coins need to be transferred to, as well as the amount of coins that we're going to be transferred to. A few things to improve on this specific implementation. You would want to like probably keep track of like what the current balance of the coins is for this address. There's more ERC20 functionality that'll help you do that. But this, I wanted to just like show you specifically how you would access the ERC20 methods from this contract. So we have this because we took the CoolCoin instance when we initially deployed the address specific from this contract over here. So again, make sure you kind of like when you're implementing this, if you're doing this in like a real world project, you'd want to do more things like checking for, what the current balance is of this, because if you have too many contributors, eventually you're going to get to a point where like, oh, I actually went over my 50,000 coin limit or whatever. So we're not going to look into that right now, but this is just so you're aware on how you can actually implement all of the ERC20 methods yourself within the ICO contract. Cool. So this is one of like a very basic bare bones implementation of contribution. In real life, you might want to do things like, allow people to contribute, and then once they meet a certain limit, or once like the ICO reaches that limit, then they receive the tokens. That would probably be like a more like real life way of doing this. If you would do that, then you'd probably keep track of like contributions inside of a mapping similar to this, where you would like map the addresses and the contribution they made. And then like once your ICO meets like a fundraising goal or something like that, at that point you would allow users themselves to then like redeem the ICO, or you can like implement like a airdrop or something. Kind of like depends on like how you want to architecture it. It's kind of like that design would be up to you, but that's like another consideration to make here. Cool. So I've got my function for contribution. One last thing, people are sending us money, right? We should be able to take that money out, because why do we want to keep it in a smart contract? We want to use it. So last thing I'm going to show you how to do is implement a withdraw function. The withdraw function is going to take an address to, just in case like you don't want to send it specifically to your own address, but you want to send it to like a treasury address or something like that. We should be able to do that. And again, this is going to be an external, but only the owner can call it. Now, I'm going to show you the preferred way of actually transferring like regular funds within a smart contract. And we're going to use this to.call to take a value. The value is going to be the balance of this address. Ooh. And let's see, it can take quotes like this. You can take a look up this syntax for like sending funds. This is the preferred method versus doing something like, payable. I think it's called send or transfer. Or I don't know the actual keywords off the top of my head because I've just been doing it this way. But doing it like the other ways for like using the payable to send the funds from like a contract to another address has some limitations because there's like a certain like hard coded amount of gas that is also sent to the other user. In order to like go past that hard coding, this would be the best way to actually send funds from a contract to another address. And then we're just going to require that this be a success. If it's not a success, we will do something like the withdraw failed. See where I messed up. Oh, I put addresses. Address. I did not spell address right. There we go. All right. So here is our very basic bare bones implementation of an ICO contract. So I'm going to go through this again real quick on like what it can do, on what you can do to kind of like build on top of this and essentially turn this into something that's actually something you can put out on mainnet. Again, with the caveat that you should talk to someone before you do that. But like I said in the beginning, we're going to have a specific ICO exchange rate. For every Matic that you contribute, you will get 2 times the amount of cool coin. There's going to be a contribution limit of 200 Matic. It says Ether because Solidity wants us to write Ether. We take consideration of who the owner, the cool coin initial contract for the ERC20 coin itself. We also have a Boolean that checks if this is like in a public phase or not. In some contracts, you may do something like you may have like multiple phases, like maybe there's like an initial seed phrase, like seed investor, and then there's like an allow list, et cetera, et cetera. So if you have like multiple phases, instead of a Boolean, you might do something like using an enum. So that'll allow you to do like a little bit more complex, like different phased ICO allow list features. And then finally, we just have a mapping that keeps track of different addresses and whether or not they are allowed to actually, transact during the allow list, during the non-public phase. We have a couple of custom errors that we wrote. One for letting folks know who the owner is if we try to use an owner gated function, and then an unauthorized functionality with some message of like why they're not allowed to do this. In the constructor, we're just taking the owner who deployed the Coolcoin ERC20 as well as the Coolcoin instance itself. We wrote a modifier. So instead of bringing in the Open Zeppelin ownable, we just wrote a very quick modifier ourselves to make sure that only the owner is able to access certain functionalities. We wrote a toggle public function that toggles that public functionality on and off, an allow list addition function that allows you to add or block certain addresses. Whether or not this is a decentralized or centralized approach is totally up to you. I'm just showing you what to do. I know there are folks who have like philosophical issues with something like this. That is something you kind of have to decide yourself. I'm simply showing you how to do it. And then a very basic contribution functions, which I mentioned, can be improved, can be changed depending on how your ICO works. In this specific instance, all we're doing is checking on the phase of whether this is public or not, if the person is on an allow list, and then if they contributed 200 Matic, and then finally accessing the ERC20 method of transfer to send the ERC20 tokens to the end user themselves, and finally a withdraw function that will allow you to go ahead and do that. On Remix, if you wanted to go ahead and deploy this, as long as you've got this check mark, you're kind of good to go. but you would switch this over to injected Web3 provider, which will connect to your MetaMask. And you can go ahead and deploy the contract, just making sure you're deploying the correct one. We want to make sure we're doing the KuCoin contract itself. And the KuCoin contract doesn't require too much else. It is hit deploy, confirm, and cool. We have deployed our contract, and we are good to go from there. To one thing that I probably should have done is probably keep track of the actual address. So caveats of live coding, the actual address that this ICO was actually sent to, so that we can actually access it. So you probably, I did the actual address. Oh, I remembered to do that. Nice. But yeah, we would just kind of like take a look at the address that the ICO itself is sent to, and using that, we can then look at the specific ICO contract at that address. Did I not do that actually? Yeah, I didn't do that. So, haha to me. Okay, I guess. So we can write like some function in here that says like get ICO address to get the address, and then test out the functionality of this. But for now, again, this is sort of like the basic implementation of like how you would do this. I apologize if my voice is a little off today. Just came back from like an IRL hackathon and conference, so I'm a little out. But hopefully this was useful to all of you. Again, I do definitely want to stress that this is an untested, unreviewed amount of code. We did this kind of live from scratch. I had a few notes that I went off of, but if you were to implement this in real life, always get a third-party reviewer to take a look at your code before implementing this and putting it out in the real world. With that, I would love to open it up to any questions.
I do see that we have one question in the chat. I'm going to try to phrase it a little differently. So I think the question is it possible when you're generating the asset to send it directly to the liquidity pool? You'd have to create the liquidity pool first, if I'm understanding the question correctly. Yeah,
you'd have to create the liquidity pool, and like at the end of the day, like when you're deploying like this this piece over here, like you can mint some to, I minted everything to this specific ICO, but maybe I'll have a treasury. Maybe there's some other, things that should hold some of this coin. I can just add in additional functionality here that mints a specific amount to a treasury, etc., wherever I want.
Now, when you see, I'm just trying to think how to ask this the best way. What's the best practice there to have the initial contract, distribute it to where it's going to go, or to do that after you deploy the asset? What do you see more often than not?
I feel like it's probably best to do it on the creation of the contract, because at that point, it's hard coded into the smart contract. Before the smart contract goes live, you kind of specify, this is where this is going to go. This is where this is going to go. Once it's deployed, that's it. There's no like, there's less room for error on like, how you're going to, do things. And like, people are people. They tend to like not want to do certain things. But if it's hard coded into the contract, then I guess we go with the whole code is law kind of philosophy and making sure that, it is where it's supposed to be.
Perfect. So while In either case, you'd be able to prove that the funds had gone there eventually. In the case of the contractor, showing that it was the intention at the time of contract deployment to put
Yep.
the funds in that spot. I agree with you. I think that's great general tip there.
Cool.
All right. Well, I don't see any other questions in the chat at this point. Now, we are, of course, available on Discord, and in our Discord for Morales, we have a link where you can reach support through Polygon as well. So if anybody has future questions on this, maybe you're watching this on recording later on, feel free to reach out through those channels. We'd love to talk with you and hear about your dApps, what you're building, and how we might be able to help you along or encourage you to keep going, because it's going to take all of us at the end of the day. And workshops like this are meant to enable you to take that further. And of course, be careful at the same time when we reach mainnet with these powerful DeFi tools.
Yep.
Always important to use caution and make sure that we're looking into audits and stuff like that when we're going to be dealing with other DeFi participants hard earned tokens.
Definitely, yeah. I tried to make sure I stressed that a couple times during.
Oh, you absolutely did. I was just reinforcing, showing we're on the same page, as of course we are. Well, thank you again to Polygon, and the one sponsor that I think I forgot to mention earlier, Covalent, who's also part of this event, and of course, Covalent along with Multichain and Axelar. Those protocols can be combined with the Polygon submission in order to possibly capture even more prizes. That the submission deadline is this Friday at 11:59 p.m. UTC. So check your local time zone for exactly what time that is for you. It is the same deadline no matter where you are in the world.
Awesome. Good luck to everyone. Really looking forward to seeing what everyone builds.
Absolutely. Very, very much looking forward to it. Check the calendar and sync the calendar through the hackathon website. That's morales.io/Google-hackathon. And we'll look forward to seeing all of you next time. And of course, at the awards ceremony here in just a couple of weeks. Have a wonderful day and see y'all soon.